Let's start with number 3. The absolute value of b minus 1 is equal to 14. Okay, so what they have here is the number 13. They want us to see, is this a solution? Will this work if you plug it in for b? I'm sorry, this is negative 13, not positive 13. So what do we do if we want to check a solution? We just grab this guy, put it in there for b, and see, does it work? So the absolute value of negative 13 minus 1 equals 14. Is this true? Still, this is a question. This is negative 14. Is the absolute value of negative 14 positive 14? Yes, it is. Let's think about this for a second. What else would be a solution for b? This isn't a part of the question, but we could just think about it for a second. We just need the inside of this to be either 14 or negative 14. So what could we put here in place of b? Then subtract 1. So we get 14. We got negative 14 covered. Negative 13 minus 1 gives us negative 14. So what if we put a 15? 15 minus 1, that's positive 14. The absolute value of 14 is 14. So that works too. Just as a quick mental exercise there. How about 5? Number 5. The absolute value of 32 minus 6f needs to be equal to 20. Is negative 2 a solution? That's a question. That's what we want to answer. So we put 32 minus 6 times negative 2. That's our substitution we're making. It's a question. The question is, does this work? So we keep trying. 32, negative 6 times negative 2 is going to be a positive 12. So we're going to add 12. So the absolute value of 32 plus 12 is going to be 44. And that is not equal. So no, that's not a solution. Let's go to number 10. The absolute value of y is equal to negative 5. Okay, it says solve the equation and graph the solution. Is there any number that we can put in for y that the absolute value would be negative 5? The answer is no. There's no way, no solution. There's no way to take the absolute value of a number and get a negative number. It's always going to be positive. Remember that about absolute values. The absolute value of a number is just how far away that number is from 0. Okay, so a quick, just really a reminder of what absolute value is. The absolute value of f minus 5 equals 3. We're just going to find the solution, and then we're going to graph that solution. Okay, so here's what we kind of really hit the first challenge, I guess, of absolute value equations. Remember that the absolute value of a number being equal to 3, it means that what's inside these parentheses could be 3, could be positive 3. Absolute value of 3 is 3. But also what's in here could turn out to be negative 3. The absolute value of negative 3 is also positive 3. So this quantity that's inside the vertical bars there, inside the absolute value, it could be 3. Or if whatever this is turns out to be equal to negative 3, then we'll have a negative 3 in here, and the absolute value of negative 3 is also positive 3. So you solve for both of these. F is equal to 8. F is equal to positive 2. Yes. So if f is 8 or f is 2, the inside of here, if f is 8, it will be positive 3. If f is positive 2, then the inside of here will be negative 3. And there you go. We have 2 solutions. And it says to graph these solutions. This is not a difficult thing. F is equal to 2. Okay, here's, we have a 2 and an 8. We should consider what we're graphing before we graph it. So let's just throw a 2 over here. This is 2. F needs to be equal to 2. There you go. Let's put 8 over here. F needs to be equal to 8. There, we're done. I don't really worry about all the tick marks in between or anything like that. positive 2 and positive 8. As long as you know that 0 is like over here, that's the most important thing. That you just kind of know where these numbers are in relation to each other. Number 20. Okay. The absolute value of -4 minus r is equal to 4. So whatever is in here, that's what's in there, could be 4. The absolute value of 4 would be positive 4. Or, just as valid, if this turns out to be -4, then what we'll have inside of here is a -4, and we'll also have positive 4 as its absolute value. So we solve both of these for r. So we'll add 4 to both sides here. Add 4. -r equals 8, or r equals -8. Or now we'll add 4 to both sides. Add 4. That'll give us -r equals 0, or r equals 0. So these are our two solutions. And let's see, r needs to be either -8 or 0. So let's put -8 here over on the left. And 0. Fill that in. Right, and you could fill this in. This would be for we could graph all those other numbers, but it doesn't really matter. We just need to put a closed circle on 8, or -8, and a closed circle on 0 to graph those solutions. Okay. So here is let's see. Let's start with number 21 here. Just doing some more solving, just with no graphing. Okay, just phasing out that graphing. Alright, so 2d minus 5, whatever that winds up to be, whatever you put in for d, if that winds up being 13, then the absolute value of 13 is 13, so that'll work. Or if what's inside the absolute value, this thing here, turns out to be -13, and we take the absolute value of -13, it'll be positive 13. So we have 2d equals 18, you add 5 on both sides, d equals 9. Or 2d could equal -8, and d could be -4 when you divide by 2 on both sides. Okay, let's do one more just like this, just for some practice here. 7h minus 10 is equal to 4. So whatever, let's just put a little divider there. Whatever's inside the absolute value could turn out to be 4, and an absolute value of 4 would be 4. Or whatever's inside the absolute value could come out to be -4, and the absolute value of -4 would be 4. So 7h equals 14, h equals 2, or 7h equals 6, and h equals 6/7. Alright, bring that down, and let's erase that. Don't want to waste paper. That's a joke. Okay. Now a little bit of a different kind of an idea here. With this equation, and I want you to just think as I write this down, what's different about this equation from all the other equations that we have done so far? If you took time to think about it, you may have noticed that on the other side of the equal sign is another variable. We got a variable inside the absolute value and a variable on the other side of the equal sign. Okay. Well, let's see. Let's just go about trying to solve it just like we would before. Whatever's inside the parentheses here, if it comes out to be equal to x, then the absolute value of x, of course, would be x. Or if this came out to be equal to -x, 3x minus 4, if that came out to be equal to -x, then we would have the square root of negative, or not the square root, the absolute value of negative x, which would be positive x. So now we just solve both equations. We'll subtract x from both sides. It's probably the easiest thing to do. 3x minus x is going to be 2x. Minus 4 equals 0. 2x equals 4. X equals 2. There we go. If x is 2, then both sides of this equation will be equal. Okay, or both sides, I should say this equation. Both sides of this equation will be equal. Okay, but again, if whatever happens over here, if this happens to turn out to be equal to negative x, then we'll have a negative x in here, and the absolute value of a negative x is going to be positive x. So we'll solve. We'll add x to both sides. We get 4x minus 4 equals 0. And 4x equals 4, x equals 1. So 1 and 2. That's great. You'll notice, though, if you're looking in your book here, that it says to check your solution. And I'll use another example where it doesn't work out to 2 solutions, where you check your work and something goes wrong. Okay, so 35, the absolute value of x plus 24 equals negative 7x. Okay, so x plus 24 could be equal to negative 7x, or x plus 24 could be equal to negative 7x. Okay, whether it comes out to be negative 7x or negative 7x, the absolute value will be negative 7x. All right, I know that sounds confusing, but we'll just follow those steps exactly the same as we did before. Basically, we set it equal to what we see here and then the negative of that. All right, so we'll add 7x to both sides. You get 8x plus 24 equals 0. 8x equals negative 24, and x equals negative 3. Over here, we're going to get a positive 7x here, so we'll subtract x from both sides, just to keep it positive. So 24 equals 6x, and x equals 4. Seems like that's not a big deal, but here is the cut to the chase, the reason why one of these doesn't work. Remember that the absolute value of a number is always going to be positive. No matter what you say about it, it will always be a positive number. So if I take 4 and put it in here, put it in there for x, what am I going to get? I'm going to get negative 28. Negative 7 times positive 4 is negative 28. There's no way the absolute value of a number is equal to negative 28. This will not work. But if I put a negative 3 in there, negative 7 times negative 3 is positive 21. Okay, and it should come out to be 21 in here too. The problem comes when we possibly could get a negative number on this side. So if that happens, if you get a negative, get the absolute value of a number equals negative, it's not possible. So that solution is extraneous. You would discount that solution. Okay, so there you go. Checking your solution, making sure that the absolute value equals a positive number, not a negative number. All right, 43, an inequality. The absolute value of j is less than or equal to 5. All right, let's take a look at the graph. Okay, pretty simple. If this was j is less than or equal to 5, that'd be pretty simple. That would work out. This is 5, and as long as we stay to the left of that, stay less than that, we'll be good. But if we keep going forever, that'll cause a problem because we'll get down to, say, negative 6. So if j were negative 6, then you have the absolute value of negative 6, which would be positive 6, and that would not be less than or equal to 5. So we can keep going until when? Until we get to negative 5. Can't go past negative 5, go more negative than negative 5, because then the absolute value of that would be bigger than 5, and that's not what we want. So j could be greater than or equal to, actually we should, let's just sandwich this in between two things, because it's between these two values, and from our inequalities section we should know that we can put this so that j is bigger than or equal to -5, but also at the same time less than or equal to +5. 48. The absolute value of f plus 6 is less than 2. So if we kind of think in our heads about a quantity that would be less than 2, the absolute value would be less than 2. That means that this guy here needs to be less than 2, but also we can't go too far. We can't go past -2. Otherwise, the absolute value of that big negative number would be bigger than 2, and we can't have that. So somewhere in here is where we need to be. So f plus 6, actually we could, f plus 6 needs to be between -2 and +2. And now we just need to solve for f. Remember, to solve these inequalities, we need to do it to all three of these things, because like this is its own inequality, and this is a second inequality, and we need to solve and do the same thing on both sides for both of these inequalities. So when we subtract -6 from -2, you get -8. That's f. That's less than -4. So f needs to be less than 8, or f needs to be greater than -8 and less than -4. So the graph of the actual solution, this is just to help us a little bit, f needs to be bigger than -8, open circle there, and it can go all the way up to -4, but it can go any further than that, because then it would make this not true. Okay. And I'm going to say one more, 62. Just throw all sorts of crazy numbers in there just to show ourselves we can do it. 2/5 n minus 8 plus 4 needs to be greater than or equal to 12. So it doesn't look quite like what we've been looking at in these last two equations, or last two inequalities. So we're going to make it look that way. No matter what this is, it's going to be, whether the inside is positive or negative, this is always going to be the same positive number. We're going to take some positive number and add 4 and get 12. Okay, so we can safely just subtract 4 from both sides. Because if we take this number and we add 4 and get 12, it would be the same if we just took this number and made sure that it was greater than or equal to 8. Okay. So to help us see what we need this quantity to be, just maybe create a little graph here that might help us. So this quantity here, the absolute value of this quantity needs to be greater than or equal to 8. So to start, it's pretty easy to say that if it were bigger than or equal to 8, then that makes sense. Then that would work. But also, if it were any less than -8, say if it were -9 or -10 or so on, then we took the absolute value of that negative number, then that would be also bigger than or equal to 8. So this quantity here, 2/5 n minus 8, needs to be less than or equal to -8, or 2/5 n minus 8 could be greater than or equal to +8. Okay, and so now we'll add 8 to both sides, and 2/5 n would be less than or equal to, make sure, 0. And then n would be less than or equal to 0. Make sure, okay. Then add 8 on both sides for this inequality. 2/5 n is greater than or equal to 16. Multiply by the reciprocal on both sides, because we get to cancel these guys out. That's 5/2. This can cancel with 6. This will be an 8. And n needs to be greater than or equal to 40. And we need to graph this. We got 0 here, 40 here, so 0 is going to be on the left. It needs to be less than or equal to 0. Or it needs to be greater than or equal to 40. And there you go. That's it. All right. I hope that was helpful. Thanks for watching.